Right. Well, in the pure sense of a detector engineer, is what we look after is the sensors which convert the photons which we capture from space into electrical signals, and therefore we are able to store them and process them. At the bottom end of the whole stack, which is, if you consider you have the atmosphere on the top where these photons fall through, and by luck we catch them on our mirrors, and these photons are then bounced off of the mirrors, reflected down through some sort of optical instrument. And it might be just a simple system of eliminating some energies of the photons, or it could be a complex polarimeter or spectrometer. But finally, those photons arrive at a piece of silicon. And that silicon is exactly the same technology as what you use in the cameras when you take pictures and selfies. But in terms of the responsiveness and the sensitivity, the linearity and the size as well, they're much, much bigger. So these pieces of silicon, by the photoelectric effect, convert the photon into an electrical signal. And we then open a shutter on the optical part, collect the photons, they create electrons inside the detector, then we close the shutter and we read that out. And that creates an analogy in spatial dimension of what we've seen. So it becomes a photo. And that photo is then stored digitally, and you can manipulate it. You have to take out the artifacts of the instrument and the detector itself, in fact, and you arrive at some value where you see spread across the image these white spots which correspond to the intensity of those objects in the sky. And that's all we have to work on. That's the whole thing about astronomy. There's nothing else to work on.
All of the astronomy nowadays is based on detectors, right? I mean, nobody puts the eye over the eyepiece or anything like that at this point. So everything is just detectors of different sort that you put onto the focal plane of the light. All the light that the telescope gathers goes to a single point, basically. And this point, you put a detector. So the detector you put there depends on the science you want to do and the instrument and a lot of factors. So those detectors are very specialized, depending on the wavelength you are covering, the sensitivity you want. So there are lots of different sorts of detectors, but depending on what sort of detector you are using, you need to, well, characterize it at least. I mean, some people develop them. We have done some of that sometimes, but usually it's more like characterizing the device. So basically be sure that it works as it's expected. So you can do the right science with this specific detector, right? By verifying that the detector or that particular unit is okay to be used in that instrument, and that you have, lots of parameters need to be tuned in order to have it working. So that's basically it's the job. I mean, it will be selecting the detector when you are developing an instrument. It will be characterizing the detector when you have it, and it will be sure that it keeps working when the instrument is in use.